Welcome, Algebra 2. This is going to be a short one on circles. So, you've never done circles before, and they are actually pretty simple. When we finish this, you'll see. So the normal form for a circle is this is like a circle with a radius 1, center right in the middle of the graph is x squared plus y squared equals r squared. In that case, the center would be, I never have my pen set right, even though I try. There we go. Oh, and I gotta change everything else. There we go. Alright, so the center would be at 0, 0 in that case. But we go a little more advanced. Oh, the radius, by the way, also is whatever r is. And then the center for, if you want it to not be in the middle of the graph, you would write it like this. X minus some value h squared plus y minus some value k squared equals r squared. And the center in that case would be hk. So notice both terms have opposite signs as they do in the formula itself. And then the radius is still r in that case. Okay. The standard form, so that's like, this is what we call center radius form right here. Standard form looks like that. Usually you do not leave it in standard form. We usually want it in center radius form because it just makes a whole lot more sense. But we'll talk about going back and forth. So the first step is to actually excuse me, take something that's written in center radius form and turn it into standard form. So you're not going to have to do this very often, but we'll just do it real quick. So we're going to have to multiply this out, which is x minus 1 times x minus 1. This one here, same thing, y plus 2, y plus 2. In standard form, everything is equal to 0, so we're going to have to bring that 34 over in just a minute. Most people can FOIL in their heads at this point, but if you can't, you can go ahead and use the grid if you need to. This ends up just being a negative x, and a negative x makes negative 2x, and then plus 1. Same thing here. 4y plus 4. Okay, so now we want to put all the x's together. So that would be the x squared minus 2x, and then the y's, so plus y squared plus 4y. And then we assemble all of the constants in one place. So this is 1 plus 4. Then we're going to have to subtract 34. And we end up with minus 29 equals 0. So that's the standard form. We almost never want to go from standard form, or excuse me, center radius form to standard form. We always want it in center radius form. So that's the only one of notes like that. Here is the steps, but I'm going to just go through it so you can see. It's actually pretty easy. It's about completing the square again. So we're bringing back what we did last time to change like a parabola into vertex form. We're going to kind of do that twice. We're going to change each part into its own little vertex form. Okay, so we're going to first, we're starting with a standard form, and we want to change it into center radius form. That means I need to move this 3 over to the other side, and I like to do a couple things within the first step, just because I don't like to rewrite all this a million times. What I'm going to do is I'm going to write x squared, and then I'm going to skip the y squared and write minus 4x. So I'm just kind of rearranging on the fly. Then I'm going to write plus blank, because I'm going to have to complete the square for the x's. So I don't know, I'm going to have to add some other number there. Then I do the same thing for the y's. So this is y squared plus 6y. Again, I'm just rearranging these two. Plus something. I'm going to have to complete the square for the y's. And that equals, so notice I added the 3 to the other side. But these things that I added here and here, or that I will add, I'm going to also have to add them over here as well. So I like to leave the blanks open. If I have another color on hand, I'll use it. Off to the side, you get pretty good at it. You don't really have to do this off to the side as you get good at it. But take half of 4, you get 2. 2 squared is 4. So we're adding 4 to both sides. Let me change the color again. We're also adding half of 6 squared, which is 9. So I'm adding 9 to this one and 9 to this one. Okay, after that, we're pretty good. This right here is a perfect square trinomial, which can be rewritten as x minus 2 squared, just like from the last unit, or the last lesson. Plus, this is a perfect square trinomial for the y's, and that would be y plus 3 squared equals, and then we just add up all that over there. So you get 16. It also says to state the center and radius. So remember, the signs will be opposite. So our center is positive 2 and negative 3. Let me write center. And our radius is the square root of 16, which is 4. Because remember, this right here is an r squared form. So r is 4. Go ahead and try this one on your own. Pause it, and I'll show you in just a sec. So this is what you should get. Nothing different except at the very end, 20 is not a perfect square, so you can just write radical 20. And there's no real need to simplify that radical 20. If you had to, like let's say it was a multiple choice question and all these answers were simplified, then just remember that radical 20 is the same as saying 4 times 5. You want a perfect square right here, so that when you split it, radical 4 times radical 5, this comes out as a 2. So that's how you would write it simplified if you need to, but most of the time you don't need to. In this last bit, they graph a circle for us, and our job is to write it in the end in standard form. Just adds that extra little challenge. So we have to write it in standard form, but you can't go right to standard form. Instead, we're going to go into center radius form because that's the information that we have. So center is easy. So the x is at negative 5, so we switch that sign and write x plus 5 squared, plus the y is easy. We just switch that sign to y minus 4 squared equals, now we need the radius. So the problem is, while it might look like the radius this way is easy to read, it's not. They gave us this right here. And if you remember back to geometry, we can use the distance formula. Distance formula is really just like a rearranged version of the Pythagorean theorem. And the Pythagorean theorem just uses 2 legs of a right triangle. And the distance formula just uses like the fact that they're coordinates and tells you exactly how to subtract. I actually still prefer the Pythagorean theorem. So we have, let me just do a different color because it's not a part of the equation yet. So if I think off to the side, I'll write right here. A squared plus b squared equals c squared. Then my a and b are the same. They each have a length of 2 units. So 2 squared plus 2 squared. That looks like a 2, right? Equals, and I'm going to change this. Instead of saying c, I'm going to be a little more descriptive. I'm going to say r squared. And then it's just 4 plus 4 is 8 equals r squared. You don't even have to square root it. If you want to know the radius, it's the square root of 8, or radical 8. But because center radius form uses the r squared value here, I'm just going to write my 8 like that. Okay, but we need to write it in standard form. So I'm going to take the extra step here of multiplying these out. And if I'm doing all in my head at the same time, it'd be x squared plus 10x plus 25 plus y squared minus 8y plus 16 equals 8. Now all I got to do is kind of gather my constants into one spot on the left so that it equals 0. And I'm left with x squared plus 10x plus y squared minus 8y. Not equals yet. Let me get rid of that. And I need to do 25 plus 16 and then subtract 8. And you should get 33 equals 0. Okay, so let's say you did this work and you're just not sure. There are ways to do this in your calculator, but it involves like lots of extra math that you could mess up, and it's not a really good check, unfortunately. So instead, let's say you're at home and you want to know that this equation that you wrote really is the graph of the circle that they gave you. What you can do is switch over to delta math. You can't really see because over here on the left side you can just kind of see a little 2 equals 8. But I put the equation in, and it graphed me the circle, and you can see it had its center of -5, 4. So it is a really easy way. You can just type in Desmos. Sorry, did I say delta? In Desmos, exactly how it's written on your paper. You don't have to solve for y or anything. So it's a nice little check. It just takes a quick second to do. All right, I think that covers everything. Everyone have a good night.